Hey there, everybody. I'll be talking to you guys about logarithms and what's called change of base today. And it's basically how we evaluate logs that aren't base 10. So how do we use a calculator to evaluate a log that isn't base 10 or base e? Since that's what the two buttons we have in our calculator are base 10 and base e. All this time of being away from school is got me thinking about how we don't really value what we have until it's gone. And I think that toilet paper is a really good example of that. Along that line of thinking, Nola had 4 cans of alphabet soup yesterday for lunch, and then also for dinner. And then today she had the biggest vowel movement I've ever seen. Sorry, that was a little rough. What about this one? What did one fly say to the other fly? Is that stool taken? Poo jokes aren't my favorite, but they're definitely a solid 2 on my list. Okay, all right. Back onto math. So the idea of change of base is to help us figure out things like, what's log base 3 of 7, and so what you heard from Miss O'Neill is that when we say log base 3 of 7, what's that equal? What does that mean? It means 3 to what power equals 7. All right, and so we're writing out like this: 3 to the what equals 7. And so how do we figure that out, right? We know that 3 to the first is 3, and 3 to the second is 9, so it's somewhere between 1 and 2, but how do we figure that out? And so what it turns out is that what we do is we take the log, so in this case, common log, so it'd be log base 10 of 7, and we divide it by log base 10 of 3. And so I'm going to show you how that works on a calculator real quick, and that it actually does do what we want it to. And so let's hit log. So log base 10 of 7, and then go outside the parentheses there and divide by, so make sure you're on the other side of the parentheses, and then log base 10 of 3. And so we find out that's 1.771. So the idea is that what we said is 3 to the what power is 7, and so if I take 3 to the 1.7712, if I just stop there, we get something that's really close to 7. So because I rounded, so if I made it more, or I did less rounding, so 1.771243, maybe we get even closer to 7. So we see that this works. So I'm gonna formalize that with you. Okay, so this is called the change of base rule. It says for any positive numbers x, a, and b, where a and b are not 1. And so we're saying that this value here cannot be 1. So when I said log base 3, we can't take log base 1, and then we can change it to any number we want, just as long as that number is not 1. So those b values can also not be 1. So what's interesting about this is that I showed you log base 3. So there's our a value of 7. So so the 3, it does not equal 1. It's equal to log base. So I showed you log base 10 of 7 divided by log base 10 of 3. Well, what it turns out is that that base of our new log actually doesn't matter. So if we wanted to write it as a natural log, it's the same thing. So log base e, so natural log of 7 divided by log base e of 3 would also give us the same answer. And if for some reason we really wanted to, we could also rewrite it as log base 2, or any number, as long as that number wasn't 1, of 7 over log base 2 of 3. So these all would work. It's just that these two are ones that we have access to in our calculator. So we generally change it to common log or natural log because this is not something that's easy to type in the calculator, but it does work. An example that we could try to maybe make sense of how it also works for a different log base is something like log base 9 of 27. So what power would I raise 9 to in order to get 27? So if I want to use a different base other than natural log or common log, we could say, I could say log base 3 of 27 divided by log base 3 of 9. Let me fix that real quick. I'm very happy with my handwriting there. And I didn't pick 3 randomly. I set this problem up specifically to show you how it works. But the idea is that this top part says 3 to what power is 27. So I know 3 cubed is 27. So log base 3 of 27 is equal to 3. And then the denominator here, log base 3 of 9. So 3 to what power is 9? And I know 3 squared is 9. So the denominator there would be 2. So 3 divided by 2 is equal to 1.5. And so what this is saying is that log base 9 of 27, 9 to the what power is 25. So 9 to the what power is 27. So what we found out is that it should be 9 to the 1.5 power equals 27, and we can use a calculator to check that. So 9 to the 1.5, and it is 27. So we see that it works. It's just interesting. But again, generally what you will do is use common log or natural log when you're doing this in the calculator. I'm going to show you some example problems that IXL is going to have you do, and it's really pretty easy. So one part of the things you want to do is make sure you are reading the instructions. So it wants us to rewrite as a quotient of 2 common logs. So we're going to be using our common log button here when we're writing that. Since it's asking it, and then want it right in simplest form. But it says log base 9 of 24, which means 9 to the what power is 24. So remember what that question is asking. 9 to the what power is 24. So how do we figure that out? So log base 9 of 24. So the change of base rule tells us that we need to take the argument of the logarithm and put that on the numerator. That's going to go as our new log, and then the base of the logarithm goes into the denominator. How I remember this, which number goes where, is I remember that base just goes to the bottom. So this becomes log, and since they want common log, so just log of 9. And then since the base is going to the bottom, well, that leaves the argument to go to the top. So log of 24. So when you type that in to IXL, you're going to type log, or hit that log button, and then 24, and then divided by, what you want to do is hit that fraction button first. So hit that fraction button. That'll pop up a space for you. And then you'll hit the common log button, so it'll do log. And then you type 24. And then move your cursor down, so then hit that common log button again, and that'll bring up, and then log of 9, and then that'll be enough to type that in. So that'll be how you type that into the answer box. So use that fraction button. So here, again, be careful about the instructions. So here they want us to write, this is a quotient of 2 base 5 logarithms. So instead of using the common log button, they want us to use the base 5. But again, so log base 6 of 28. So the change of base formula tells us that we need to write that as a fraction. And since it wants us to do log base 5, so we're going to do log base 5. And then of, and so again, the big number here, the argument, will go to the top. So when I say big, I mean like physically larger, not numerically larger. And then the denominator will be log base 5. and then of, and so the base goes to the bottom. So there's the physically smaller number, so 6 being written smaller, goes to the bottom. So the base goes to the bottom. And so what you're going to do to type that is you're going to hit the fraction button, and that'll pop up your fraction bar. And then you're going to hit the log with the empty square by it button. And so that'll pop up a log and then a square, and so you'll type in that square of 5, and then a 28 after that. And then move to the bottom of the denominator, use your cursor to do that, hit the log base button, so it'll pop up that square down there, you hit 5, and then 6 after that. And then type that in like that, should work just fine. Rewrite as a quotient of 2 natural logarithms. So again, just want natural logs here. So I'm using this button this time. So log base 2 of 48. So 2 to the what power is 48. Since they want us to use natural logs, I'm going to hit the fraction bar, then natural log, and then 48. The argument goes on top. Move to the bottom, natural log button 2. And that's it. Pretty easy. Here we have log of 6. So remember what they're telling us here, or not? They want us to write this as 2 natural logarithms. Okay, so we're going to be using that natural log button again. So think about what they are telling us but not telling us with this. So log of 6. So remember, this is a common log. Since they didn't tell us the base, that means the base is 10. So you need to watch out for that. Want us to write as a natural log, combination of natural logs. So fraction bar, natural log button, argument goes on top. So natural log of 6, natural log on the bottom, and then since our base is 10, so natural log of 6 divided by a natural log of 10. So that would tell us what 10 to the what power is 6. Well, so what's interesting about that, now that our base is bigger than our answer, let's look at that real quick. So 10 to the what power is 6. So, oops, wrong button. So if you're using this calculator, if you're trying to do this, the function key over here is where the logs are. So natural log of 6 divided by the natural log of 10. So you get 0.778. So 10 to the 0.778 should be really close to 6. Right? So you see that using that power that's less than 1, that rational power, that's kind of like a root, but it's hard to say since it's a decimal, not like a half or something like that. But that's what's, some sort of root of 10 is giving us that smaller number. So see that it does work. And last example here. All right, so rewrite is a combination of common logs, so just pay attention to that. So we're using this button here. And again, think about what they're telling us but not telling us. So the natural log of 6, and they want us to write that as common log, so I'm going to use my fraction bar, then my common log button, so log, and then the argument goes up top, so 6 goes on top, and then the common log button here. And then what are they telling us or not telling us? So the natural log is base e. And so you type log and then e, just use the letter e, and that works just fine. So, and then type it in like that, and you'll get the answer correct. Should be pretty easy. So it's going to be, this idea of change of base is going to be really important as we go to start solving equations. It's a little preview for what we're heading into. So if I did something like, trying to solve an equation like 4 to the x equals 12. So 4 to what power equals 12. So what you learned from Miss O'Neill is that we rewrite this as a logarithm. And so this would become log, and then the base of the power is the base of the logarithm. The answer, the exponent, right, goes here. Or the answer goes there, and then the exponent, since a log is an exponent, is the answer. So that would be written as 4, a log base 4 of 12 equals x. Well, we still don't have an answer for that, and so now the change of base is where that's going to come in. So this would be rewritten as log, or common log of 12 divided by common log of 4. would be equals x. And then we'd actually be able to get that answer. So when we're going to go solve these equations, that's how we're going to do it. So this will be the next thing that we work into, is solving these exponential equations using logarithms. And so we need to know how to change base in order to do that. So, but what you guys need to be doing is looking at IXL section R6 and get that score of 80 at least on there. I've noticed quite a few of my students are going for those hundreds, so I appreciate seeing those. But I hope you guys have a wonderful day, and you're staying healthy. Bye.